Welcome to CIO Central, where we explore top-of-mind subjects, priorities, and insights through conversation with IT thought leaders in technology, innovation, and adoption. I'm Bill Miller, NetApp's CIO, and today I'm talking with Bill Peters, CIO for Aston Martin Cognizant Formula One racing team. Bill Peters has been leading IT in support of Formula One and motorsports for more than 2 decades, supporting such brands as McLaren, Lotus, Caterham, BWT Racing Point, and now Aston Martin Cognizant F1. Bill Peters, welcome.
Good to be here.
Bill, it really is a distinct pleasure to talk with you today. Can you tell us a bit more about your background and how you landed the CIO seat with the Aston Martin Cognizant Formula One racing team?
I've been in sort of sports cars and the F1 business for 25 plus years now. And in IT for 35 years. I've been in Formula One World Championship winning teams, sports car winning teams as well. You know, that's the ultimate. At that point in time, you're the best in the world at what you do, and that's quite satisfying. This sort of latest chapter is really, the cream on the cake for me. I've been a fan of Aston Martin forever. So it's really, really exciting times for us.
Bill, but I think about where you are today. We're several weeks into the Formula One season, the inaugural season for Aston Martin after a significant hiatus from Formula One racing. What's top of mind for the team, and how does that translate for you in terms of IT priorities?
Back in the days that we were Force India and Racing Point, we have been able to do an awful lot with not many resources. With the investment from Lawrence Stroll and his consortium, and then the subsequent acquisition of Aston Martin and the partnership there, we've now got resources to do things better. Absolutely key to what we want to do and to be able to compete with the big teams is our data strategy. Without a doubt, second to our people, data is absolutely key. And we generate data from lots of sources. So in the life cycle of a car, there's a lot of data being generated in the virtual environment, in the real world environments, from various applications. But a lot of this data is siloed at the moment. It's used and generated and used where it's actually needed. But we struggle to sort of get the correlation across that data. So what we're looking to do is sort of, create a data lake that we can consolidate all of this information into, where we can sort of rapidly ingest the data that we're generating, and then have a storage layer that is fit for all of our workloads. So structured, unstructured, time series data, all of those workloads. And then we need to be able to process and analyze that data and then present it back to the various consumers within the organization, either through APIs or through dashboards or reports or whatever. Ultimately, Formula One is driven by aerodynamic performance and vehicle dynamic performance, and data is essential for developing that performance.
Bill Peters, as you know, NetApp is data-driven. We're passionate about data, but yet here you're quite literally driving with data, right? I mean, it really factors in to what you do on the track and in preparation to get on the track. Can you say more about that and your unique vision for leveraging data?
We're slightly different from most businesses in that we're very performance-driven. Performance is our currency. So we're not revenue-driven per se. It's all about performance, and that performance, not just on the car, it distills down to everything we do in the business. So we either have to be very efficient, we have to be very agile, equally we have to be very reliable as well. There's no point in having the fastest car on the track if you can't finish. So this applies throughout the business. And I think when you look at the very sort of high level life cycle of the way that we build cars, we go from concepts, which could be regulation imposed, they could be from testing, the ideas that somebody's had, and then we turn those into sort of aerodynamic and vehicle dynamic experiments that ultimately will go into a wind tunnel and then onto a full-size car. And that life cycle needs to be as short as absolutely possible so that we can get any performance advantage onto the car as quickly as we possibly can. And this happens all the time. We build a car at the beginning of the season, and then we constantly update that car throughout the season to stay competitive or to become more competitive. So every stage of that life cycle, we're generating huge amounts of data that drives decisions on whether to proceed to the next stage, really. And if you took aero development as an example, so we go through an iterative cycle whereby we run sort of candidate components, if you like, through a virtual wind tunnel. We do lots of iterations in the virtual world because it's much more, A, it's faster, and B, it's much more economic to do that. And then we'll take likely candidates from those results and put them through the wind tunnel. So obviously, we need good analytics around that and be able to A, optimize what we put into the sausage machine in the first place, and B, make sure that we're going to get some good correlation between the virtual world and the physical wind tunnel world. If that then looks very promising, then we'll build full-size components, and we'll put those onto the car, and they'll get data from the car, and we'll correlate that back to the wind tunnel. Our virtual wind tunnel, for example, it's a supercomputer, and it is dedicated purely to this type of simulation. It's got lots of pre-processing nodes. It's got lots of solver nodes. I think it's something like 3,500 cores. A couple of petabytes of storage hanging off of that. All just so that we can simulate aerodynamics performance without going into the wind tunnel. Now, we're actually governed around how much of that compute power we can use for a given period of time. And the same with the wind tunnel. We're actually governed on how much time we can spend in the wind tunnel. So this, again, is to try and enforce regulation to stop there being an arms race between the teams, and buying bigger and bigger and bigger supercomputers, etc. So what that means to us is that we have to absolutely optimize the tools that we have.
Bill, that's fascinating. I want to follow up a little bit on this notion of this data-centric differentiation. How do you take that data, the race day data, the R&D data from the wind tunnels and other environments, and marry that into this constant evolution to gain competitive advantage?
The golden fleece for us really is the convergence of the output from all of the various simulations that we do in the real world. So if we could make the virtual wind tunnel results very convergent with the real car results, we could actually cut out the wind tunnel. When you go from the concept within a virtual wind tunnel simulator, or even a driver in the loop simulator, which is like a big games machine, that feedback, those iterations are quite frequent, and we're putting lots of data in and getting select results out. The iterations then get smaller and smaller as we get nearer to the car. So the number of iterations through the wind tunnel are much, much lower. So we have to make sure that we get the right candidates during the period of time we've got there. And then we have to have a very strong level of confidence to actually manufacture these parts. Because some of these parts are, hundreds of thousands of pounds. So you have to have a lot of confidence to say, right, we're going to build one of these and put it on the car. Because if it doesn't work, that's just money down the drain. So the optimization and and the feedback loops that go on all the time. So once we get onto the car, there are 300 sensors on a car, up to 500, and thousands of channels of data that come off the car that we're monitoring for various reasons. But one of which is the feedback into that whole life cycle loop. So I think that's the sort of key to the whole R&D piece. This is this constant evolutions, these constant iterations, and the constant experimentation and the feedback loops.
Most CIOs have enough of a challenge on their hands with a complex but largely static global IT infrastructure. For you as CIO of a traveling racing team, you're driving a high-powered IT engine around the world on a challenging schedule. You got to be there for the next event. In that context, what demands does this notion of mobility place on your IT framework that you've dubbed your racing fabric? I love that expression, the racing fabric. And what are the related information technology concerns that keep you up at night associated with that?
The environment we take to trackside has to be really robust. It's got to be very resilient. We've got to have plenty of redundancy built into it. This environment gets set up and packed away again 25 to 35 times a year. And the environments that we're working in are extremes. Sometimes we'll be in very hot, humid environments. Sometimes we'll be in very hot, dry environments. Sometimes we'll be in cold, wet environments. But equally, another practical consideration is that we ship this all over the world, so we have to keep the weight of these systems down, and try and keep the footprint down as well. So often what we'll do is we'll actually buy 5 sets of things and we put them in sea freight. So when we're going to China, we'll send a boat there first, and we'll get the kit when we get there. And equally, if we're going to Australia, then we'll send a boat there. Once we get this environment set up, we need to serve the needs of the race support team at the event, but we also have a team of people back at the factory in mission control, essentially a virtual pit wall. So if you took just a free practice session, for example, we have race engineers who are talking to the drivers. They're talking about the program that they're going to be running. They're talking about conditions. They're talking about track positions, etc., etc. So these are the main communication links to the drivers. These race engineers are supported by performance engineers. These are the guys that look at how the car and driver are performing. So, if they're braking too soon into a corner, if there's too much oversteer, too much understeer, all of these sort of things. These guys are the ones who are monitoring that and feeding that to the race engineers, so the drivers can make real-time adjustments, or they can address it when they go out with the next session. We also have control engineers, and control engineers are sort of monitoring the vital statistics of the car. So they are checking oil pressures and aero pressures and temperatures and all of these things. And again, that's all being fed back in real time to the drivers to control the closeness to drivers in front, so they can reduce the heat on the tires and on the engine, etc., etc. And the sort of fourth feed into that is the strategy engineers. So we've then got some very clever people. They're using very clever tools to try and predict what's going to happen. A, let's have a plan of what we're going to do, and then B, let's be very adaptable to change to certain circumstances. So if there's a crash, if there's a safety car, if somebody comes in for a pit stop early, we have to be able to react to that, and that all has to be communicated back to the race engineers, to the driver. We then have tyre analysts. You alluded to it, aero performance engineers, vehicle performance engineers, and these are all analysing and feeding back information for their specialities. So, again, this may be channeled real time to the drivers, or it may be used for the following session. But these engineers are all depending on data that's coming off the car in real time. Data then also comes off the car when it gets back to the garage. So we're actually getting live telemetry off the car, but that's a subset of the actual full data that we can get from the car. So we're using that subset of data for real time reactions, etc. And then we use the full data set for bigger analysis and historical comparisons and all those good things. So then you couple that with other sources like GPS, where the parallel simulations that are going on in the factory, etc., etc. You can imagine there's a lot of traffic, there's a lot of data flying around, and there's a lot of people depending on that traffic. Equally, whilst we've got that real time for the guys at track, we need that in very near real time for the people at the factory as well, because again, they need to get subsets of that data and do their analysis on it. So obviously the communications between every event that we go to have to be really robust as well. We have to have guaranteed bandwidth, because whilst we can work autonomously, if we lost comms to the factory, we'd lose a lot of performance because of that. So we have to have really good comms. So it is a traveling circus, and it's incredibly critical.
You and I can hardly go anywhere today without talking about or hearing about cloud. Cloud is on the front page news for everything IT. How does hybrid cloud factor into your technology vision?
To be honest, we were quite late to the party as far as cloud's concerned. So, historically, Formula One teams have been, very, very on-prem biased, very protective of our data and all those good things. But we realise without a doubt that the hybrid cloud scenario is the way to go. We've got opportunistic things in the cloud. The normal productivity tools, all those sort of good things. But what we see now with the hybrid scenario is kind of one of the corners of the triangle as far as the data fabric is concerned. So we have lots of data that we're generating trackside, or we have lots of data that we're generating in the remote wind tunnel, and then we have data back in the factory. So those remote sites, we need to be able to process data at those sites. We need to be able to communicate between those sites. But equally, we need a central point somewhere between the two where we can consolidate data and create our data lakes, and then serve that whole consumption layer back to the consumer. So we really see that as where hybrid is coming into its own. We can see even possibilities where we can actually get access to data faster by more of our clients than we could just by having that sort of direct transfer, because we've got this midway point. Equally, I think we do a lot of parallel processing, etc., on-prem at the moment. And whilst we do need that performance locally, we equally need to be able to burst that capability and increase that capacity, etc. So obviously that's another area where hybrid cloud really plays into its own. And we've just we're sort of fairly again recent to the Kubernetes and the containerization game as well. But we're doing more and more in that, and certainly we've got quite an extensive on-prem environment for that. So we very much see that cloud Kubernetes capability, so that we can mix and match workloads and all of those good things as a key pillar of our sort of strategy going forward.
No pun intended here, but I'm going to switch gears for a minute. How did Aston Martin, Cognizant, Formula One choose NetApp as a partner in the fulfillment of this truly compelling vision? And ultimately, how do we best serve you through this partnership?
Obviously, we could see that NetApp were a market leader. We went out with a very targeted outlook on what we were looking for. And looking for the foundations to what we want to build on, NetApp fit the bill. So, when we initially started talking to the team, the thing that really immediately made you stand out from the competition, and what really attracted us, was the whole concept of the data fabric. So we've stolen the race and fabric terminology from you guys, really. It really fits with what we're trying to achieve, i.e. to have the right storage and compute for the right workloads, and where they're needed, and then making them all talk together as seamlessly as possible. Subsequent conversations, the more and more in depth we got around what we were trying to achieve, it became apparent it was not just about sort of the data pipeline and the infrastructure that you could help us with, but then looking at the edge computing side of things, to push out the compute capability to where the guys need it. So instead of necessarily having to ship data back, maybe we can process it at source. That's an immediate advantage for us. Very interested in the cloud Kubernetes offering. That's again, it's something that we were looking to migrate to, but it's something that we can now accelerate. We're looking at how can we have an environment trackside, for example, that we can repurpose. So when it's between sessions and not doing anything, it can be GPU heavy and can do some, machine learning, analysis, crunching, etc. We can also use it for digital workplace stuff, VDI trackside, instead of having people taking laptops and what else have you. Let's give them virtual desktops. And then during sessions, we ingest and process and store data at very high speed. We started off with a sort of best in breed view of what we wanted, and NetApp fitted that. And then we discovered that there were a whole other raft of things that would also bring benefit. So before we even started, really, the whole relationship blossomed and sort of expanded to a wider remit.
Well, we're very excited about the partnership. We've got a lot of enthusiasm and a lot of trackside fans here in the company. And it was really interesting to hear you talk a little bit about cloud and potential advantages. We see a lot of our customers looking to leverage cloud to gain some additional capabilities, through those cloud marketplaces to analyze data, to process data. What do you see as truly unique and different about this experience and this place in time with Aston Martin Cognizant F1?
We've now got the brand behind us. We've now got the right partners alongside us. We've got the right people. We've got very good people that have been resource staff. So given them the resource that they need, giving me the resource that I need, we can achieve great things. And we strongly believe that we can compete with the big boys and beat them. So I think that's it. I want at least one more World Championship before I retire.
Well, that's exciting. We're clearly pulling for you, and we're going to try to do everything we can to help and do our part to make that come true. All right, Bill, we're on the metaphorical last lap here. So let's close out this discussion on a winning note. What's one thing that few people know, but that everyone should know about the Aston Martin Cognizant Formula One racing team?
I think, the stars really are aligning. As I said, we've got a culture of achieving, and punching above our weight. With Lawrence Stroll and his consortium, there is a group of people that are passionate about making this a success. They're not in it for the money; they are in it for the passion. And that reflects the passion that we all have as well. We're used to taking risks, and we're used to focusing very much on the goal. And now with that backing, we can focus on greater things. And I think all of these things have come together now. Watch this space.
Bill Peters, it's been such a rare treat talking with you about data and IT in the world of Formula One. I'd love it if we could talk again in a few months and see what new insights you can share. Does that sound like a good idea?
I'll be happy to do that. Yeah, really, really good idea.
That's all for today. Thanks again for joining us on NetApp CIO Central, and make sure you stay data-driven.